In this video, we're going to look at an example of calculating the area of a surface over a region in the xy plane. So we're looking at the surface z equals 1 plus 3x plus 2y squared, and it lies above the triangle with vertices 0, 0, 0, 1, and 2, 1. So first, looking at the region that we're integrating over, we've got here's our line x equal to 0, here's our line y equal 1, here's our line y equals 1/2 x, or x equals 2y, depending on which way we want to express it. Notice that this region is not horribly bad to express in terms of y first or x first and then y, or y first and then x. It's both vertically and horizontally simple here. We don't have to worry about having issues with having to break up our integral into multiple pieces if we try to do one over the other. So this region is not really telling us what order to integrate with respect to, but let's look at our integrand. When we look at our surface area, when we do the square root of 1 plus each of the partials, the sum of the partials squared, we notice that we get a y squared under our radical, and then the x term goes away when we take our partial. So since I have a y squared under the radical, to do this with respect to y first would be difficult because I would need to use some sort of a trig substitution to get at it, or use one of our integrating table of integrals to be able to write down an antiderivative. That's just a harder way to do it. So let's instead integrate with respect to x first. Well, if I want to integrate with respect to x first, then I need to express x as functions of y, which means that we're going to integrate over horizontal slices first and then integrate with respect to y. So our x bounds, this is x equal to 0, this is x equal to 2y, and we see that all the way up, that those are our boundary curves. So our inside integral will go from 0 to 2y, our outside integral is how far the y's go, 0 to 1, and then we have dx dy. This is in terms of y with no x's, so its antiderivative is just x times that constant as far as x is concerned. Plug in 0 to 2y. Now we get a 2y out in front, which makes our antiderivative much easier. You can check if you do your u substitution. You should get 1/24 times 10 plus 16y squared to the 3/2. And if we put in 0 and 1, this expression should be what you get when you put in 0 and 1 in for y.